Hello everyone, I am Naren. Welcome to today's topic. I am your guide for this topic. In today's topic we are going to see Topic 1. Countersinking, counter-boring and spot facing. Topic 2. Reamers, reaming and its procedures. Production and manufacturing. Fitter drilling. Topic 1. Countersinking. Objectives. At the end of this topic you shall be able to state countersinking. List the purposes of countersinking. State the angles of countersinking for the different applications. Name the different types of countersinks. Distinguish between Type A and Type B countersink holes. Countersinking. Countersinking is an operation of beveling the end of a drilled hole. The tool used is called countersink. Countersinking. Purpose of countersinking: to provide a recess for the head of countersink screw. To deburr a hole after drilling. For accommodating countersink rivet heads. To chamfer the ends of the holes for thread cutting and other machining process. Countersinking angles and its purpose. 75° used for countersink riveting. 80° used for countersink self-tapping screws. 90° used for countersink head screws and deburring. 120° used for chamfering ends of holes to be threaded or other machining processes. Types of countersinks and uses. Commonly used. Multiple cutting edges with taper shank. Multiple cutting edges with straight shank. Special countersinks. 1 or 2 flutes for countersinking small diameter holes. Countersink with pilots, for precision countersinking needed for machine tool assembling. And for after machining process, particularly for heavy duty work. Note: the pilot is provided at the end for guiding the countersink concentric to the holes. Countersinks hole sizes. The types of countersink holes according to Indian Standard IS 3406, Part 1, 1986. Type A. Type B. Type C. Type E. Type A countersink holes. Type A countersink holes are suitable for slotted countersink head screws, cross-resist and slotted raised countersink head screws. These screws are available in two grades, that is medium and fine. Type B countersink holes. Type B countersink holes are suitable for countersink head screws with hexagonal sockets. Type C countersink holes. Type C countersink are suitable for slotted raised countersink, oval, head tapping screws and for slotted countersink, flat, head tapping screws. Type E countersink holes. Type E countersink are used for slotted countersink bolts, that is used for steel structures. Hi guys, let's try the question session. Try to answer the following question in 10 seconds. How many types of countersink hole sizes are used as per Indian standard? Option A, 4 types. Option B, 3 types. Option C, 5 types. Option D, 6 types. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option A, 4 types. Let's move on to next section of this topic. Topic 1. Counter boring and spot facing. Objectives. At the end of this topic you shall be able to differentiate counter boring and spot facing. State the types of counterbores and their uses. Determine the correct counterbore sizes for different holes. Counter boring. Counter boring is an operation of enlarging a hole to a given depth to house heads of socket heads or cap screws with the help of a counterbore tool. Counterbore tool. The tool used for counter boring is called a counterbore. The counterbore will have 2 or more cutting edges. Spot facing. Spot facing is a machining operation for producing a flat seat for bolt head, washer or nut at the opening of a drilled hole. The tool is called a spot facer or a spot facing tool. The spot facing also done by fly cutters by end cutting actions. Note: tools that are used for counterboring can also be used for spot facing. Counterbore sizes and specification. Counterbore sizes are standardized for each diameter of screws as per BIS. Types of counterbores. There are two main types of counterbores. Type H. Type K. Type H. The Type H counterbores are used for assemblies with slotted cheese head, slotted pan head and cross-resist pan head screws. Type K. The Type K counterbores are used in assemblies with hexagonal socket head cup screws. While representing counterbores in drawings, counterbores can be indicated either by code designation or using the dimensions. Using code designation. Using the dimensions. Okay guys, let's try the question session for this section of topic. Try to answer the following question in 10 seconds. What is the name of the operation of enlarging a hole to given depth? Option A, countersinking. Option B, counterboring. Option C, spot facing. Option D, drilling. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option B, counterboring. Let's move on to the next topic. Topic 2. Reamers. Reamers. Objectives. At the end of this topic you shall be able to state the use of reamers, state the advantages of reaming, distinguish between hand and machine reaming, name the elements of a reamer and state their functions. Reamers. A reamer is a multipoint cutting tool, used for enlarging by finishing previously drilled holes to accurate sizes. Advantages of reaming. Reaming produces high-quality surface finish, dimensional accuracy to close limits. Also small holes which cannot be finished by other processes can be finished. Classification of reamers. Reamers are classified as hand reamers, machine reamers, classification of reamers. Hand reamers. Reaming by using hand reamers is done manually, for which great skill is needed. Hand reamers have straight shanks with square at the end for holding with tap wrenches. Machine reamers. Machine reamers are fitted on spindles of machine tools and rotated for reaming. Machine reamers are provided with Morse taper shanks for holding on machine spindles. Parts of a hand reamer. The parts of a hand reamer are listed here. Axis. The longitudinal center line of the reamer. Body. The portion of the reamer extending from the entering end of the reamer to the commencement of the shank. Risses. The portion of the body which is reduced in diameter below the cutting edges, piolet or guide diameters. Shank. The portion of the reamer which is held and driven. It can be parallel or taper. Circular land. The cylindrical ground surface adjacent to the cutting edge, on the leading edge of the land. Bevel lead. The bevel lead cutting portion at the entering end of the reamer cutting its way into the hole. It is not provided with a circular land. Taper lead. The tapered cutting portion at the entering end, to facilitate cutting and finishing of the hole. It is not provided with a circular land. Bevel lead angle. The angle formed by cutting edges of the bevel lead and reamer axis. Taper lead angle. The angle formed by cutting edges of the taper and reamer axis. Terms relating to cutting geometry. Flutes. The grooves in the body of the reamer, to provide cutting edges, to permit removal of chips, and to allow the cutting fluid to reach the cutting edges. Heel. The edge formed by the intersection of the surface left, by the provision of a secondary clearance and the flute. Cutting edges. The edge formed by the intersection of the face and the circular land or the surface left by the provision of primary clearance. Face. The portion of the flute surface, adjacent to the cutting edge, on which the chip impinges as it is cut from the work. Rake angles. The angles in a diametral plane formed by the face and a radial line from the cutting edge. Clearance angle. The angle formed by the primary or secondary clearances, and the tangent to the periphery of the reamer at the cutting edge. They are called primary clearance angle and secondary clearance angle respectively. Helix angle. The angle between the edge and the reamer axis. Hand reamers. General features of hand reamers. Hand reamers are used to ream holes manually using tap wrenches. These reamers have a long taper lead. Most hand reamers are right-hand cutting. Helical fluted hand reamers have left-hand helix. The left-hand helix will produce smooth cutting action and finish. Note: most reamers, machine or hand, have uneven spacing of teeth. This feature of reamers helps to reduce chattering while reaming. Types, features and functions of hand reamers. Features. Hand reamers with different features are available for meeting different reaming conditions. The commonly used types are parallel hand reamer with parallel shank, hand reamer with pilot, socket reamer with parallel shank, taper pin hand reamer. Parallel hand reamer with parallel shank. A reamer which has virtually parallel cutting edges with taper and bevel lead. The body of the reamer is integral with the shank. The shank has the nominal diameter of the cutting edges. One end of the shank is square-shaped for tuning it with a tap wrench. Parallel reamers are available with straight and helical flutes, and it's commonly used hand reamer for reaming holes, with parallel sides. Hand reamer with pilot. A portion of the body is cylindrically ground to form a pilot at the entering end. The pilot keeps the reamer concentric with the hole being reamed. Socket reamer with parallel shank. Socket reamer with parallel shank has tapered cutting edges to suit metric Morse tapers. The shank is integral with the body, and is square-shaped for driving. The flutes are either straight or helical. The socket reamer is used for reaming internal Morse tapered holes. Taper pin hand reamer. The taper pin hand reamer has tapered cutting edges for reaming taper holes to suit taper pins. A taper pin reamer is made with a taper of 1 in 50. These reamers are available with straight or helical flutes. Uses of straight and helical fluted reamers. Straight fluted reamers are useful for general reaming work. Helical fluted reamers are particularly suitable for reaming holes with keyway grooves, or special lines cut into them. The helical flutes will bridge the gap and reduce binding and shattering. Material of hand reamers. High-speed steel material is used for a one-piece construction reamers. As for two-piece construction reamers, cutting portion is made of high-speed steel, shank portion is made of carbon steel. They are butt welded together before manufacturing. Specifications of a reamer. Reamer is specified based on type, flute, shank end, size. For example, hand reamer, straight flute, parallel shank of diameter 20 mm. Drill size for reaming and its conditions. For reaming with a hand or a machine reamer, the hole drilled should be smaller than the reamer size. The drilled hole should have sufficient metal for finishing with the reamer. Excessive metal will impose a strain on the cutting edge of the reamer and damage it. Calculating drill size for reamer. The following formula is applied in workshop for calculating drill size. Drill size is equal to reamed size minus undersize plus oversize. Here, finished size is the diameter of the reamer. Undersize is the recommended reduction in size for different ranges of drill diameter. Undersizes for reaming. Diameter of ready reamed hole, mm. Undersize of rough bored hole, mm. Under 5. 0.1 to 0.2. From 5 to 20. 0.2 to 0.3. From 21 to 50. 0.3 to 0.5. Over 50. 0.5 to 1. Oversize. It is generally considered that a twist drill will make a hole larger than its diameter. The oversize for calculation purposes is taken as 0.05 mm for all diameters of drills. For light metals, the undersize will be chosen 50% larger. For obtaining good surface finish while reaming operation, use a coolant while reaming. Remove metal chips from the reamer frequently. Advance the reamer slowly into the work. Note if the reamed hole is undersize, the cause is that the reamer is worn out. Defects in reaming, causes and remedies. Reamed hole undersize. If a worn-out reamer is used, it may result in the reamed hole bearing undersize. Do not use such reamers. Always inspect the condition of the reamer before using. Defects in reaming, causes and remedies. Surface finish rough. The causes may be any one of the following or a combinations thereof. Incorrect application. Swarf accumulated in reamer flutes. Inadequate flow of coolant. Feed rate too fast. While reaming, apply a steady and slow feed rate. Ensure a continuous supply of the coolant. Do not turn the reamer in the reverse direction. Determining the drill size for reaming. The formula used to drill size for reaming is drill diameter is equal to reamed hole size into undersize plus oversize. Okay guys, let's try the question session for this section of topic. Try to answer the following question in 20 seconds. Calculate drill size for reaming 10 mm if the undersize is 0.2 mm and oversize is 0.05 mm. Option A, 9.80 mm. Option B, 9.75 mm. Option C, 9.95 mm. Option D, 9.70 mm. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option B, 9.75 mm. Let's move on to the next topic. Topic 2. Reaming and its procedures. Reaming. Objectives. At the end of this topic you shall be able to state the procedure for hand reaming and machine reaming. Reaming. Reaming is the operation of finishing and sizing a hole which has been previously drilled, bored, casted holes. The tool used is called a reamer, which has multiple cutting edges. Manually it is held in a tap wrench and reamed. Machine reamer are used in drilling machine using sleeves, or socket. Normally the speed for reaming will be 1/3 speed of drilling. Hand reaming working procedure. Drill holes for reaming as per the sizes determined. Place the work on parallels while setting on the machine vise, as in below figure. Chamfer the hole ends slightly. This removes burrs and will also help to align the reamer vertically. As in below figure. Fix the work in the bench vise. Use vise clamps to protect the finished surfaces. Ensure that the job is horizontal. Fix the tap wrench on the square end and place the reamer vertically in the hole. Check the alignment with a tri-square. Make corrections, if necessary. Turn the tap wrench in a clockwise direction, applying a slight downward pressure at the same time. As in below figure, apply pressure evenly at both ends of the tap wrench. Apply cutting force. Turn the tap wrench steadily and slowly, maintaining the downward pressure. Do not turn in reverse direction, it will scratch the reamed hole. As in below figure. Ream the hole through. Ensure that the taper lead length of the reamer comes out well and clear from the bottom of the work. Remove the reamer with an upward pull until the reamer is clear of the hole. As in below figure. Remove the burrs from the bottom of the reamed hole. Clean the hole. Check the accuracy with the cylindrical pins supplied. Okay guys, let's try the question session for this section of topic. Try to answer the following question in 10 seconds. What is the name of the holding device? Option A, bench vise. Option B, machine vise. Option C, swivel base vise. Option D, universal vise. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option B, machine vise. I hope you gained a plenty of knowledge from today's topics. Thank you. For queries, visit www.nemelearningonline.in/Moodle.